Alright, we are back at it with lesson 1.3. Today we are going to be learning about the midpoint and the distance formulas. So, first off we have two terms we have to talk about before we get to our formulas. So the first one is that term midpoint. Okay, so what is a midpoint? Pretty simple. Midpoint is the point in the middle of a segment. A point in the middle of a line segment. Right? You cannot have a midpoint for array because array has a starting point and no ending point. It goes forever. You cannot find the middle of it. You cannot find the middle of a line. Since a line goes forever, you can't really find the middle of it. Alright, it could be, if I move it to the left a little bit, it still goes forever to the left and forever to the right. So if I move that point off to the right maybe, that line goes forever to the right, forever to the left. So you can't really find the middle of a line either. So a midpoint is a point in the middle of a line segment. It will create two congruent segments. We talked about congruent segments back in lesson 2. Alright, so that's a midpoint. It will look something like this. So I've got a segment here. Let's just call it, that's a really bad H. Alright, here we go. H, I. Okay, point right in the middle. Alright, we can call that, M. This is congruent to this. Remember when we put marks on like that, it means they are congruent. They're the same. Alright, so if M is the midpoint, then it is true that HM is congruent. Remember that symbol from the other day, that congruent symbol? To MI. Alright, that's midpoint. First term. Second term, segment bisector. Segment bisector. Alright, bisect. Okay. Bi means two, sect means to cut. So this means to cut into two equal pieces, or to cut into two congruent pieces. Right? So a segment bisector is anything that cuts a segment into two congruent pieces. So very similar to a midpoint, but slightly different. Right? So let's say we've got AB here, and C is my midpoint. Sometimes we put, in this case, like 2 marks on each of those. Alright? Now, C is the midpoint. Anything that goes through C would be a segment bisector. So maybe it's another segment. Or maybe it's a line. Put some arrows on it. This is a segment bisector. It is something that cuts this segment into 2 equal pieces. Right? Segment bisector. Anything that cuts a segment into 2 equal or into 2 congruent pieces. Alright? Now we're going to take a quick look at some examples for midpoints and segment bisector, and we're going to come back and hit our other 2 things. So, first, I want you to copy this information down. Alright? So, we got XMP, a segment, M is the midpoint. So that means XMP is all in a nice straight line there, collinear. XM equals 3x plus 2, MP equals 5x minus 10. We are going to solve for x, and then you're going to find XP. Remember we talked about this the other day when it says find XP. There's no symbol here, so it means find the length of XP. So copy this down, pause the video as you need to, come back and look at it in just a second. Alright, you should have paused that, solved it. Let's take a look at it. What does it look like? So, XM is 3x plus 2. 5x minus 10 for this other part. Midpoint means that these 2 pieces right here are congruent. They must be equal. So we're going to set up an algebra problem. 3x plus 2 equals 5x minus 10. Alright, so let's subtract 3x from both sides. These cancel. 2 equals 2x minus 10. Let's add 10 to both sides. These cancel. 12 equals 2x. Let's divide both sides by 2. 6 equals x. Alright, now, we haven't finished the problem. Remember the problem said solve for x and find xp. So we're going to take this 6 and we're going to substitute it back in right here. We're also going to substitute it back in right here, and first off we're going to check to see if our answer makes sense. So 3 times 6 is 18, 18 plus 2 is 20, 5 times 6 is 30, 30 minus 10 is 20. All right, that's good. They're equal. If for some reason these were not equal to each other here, then that means you did something wrong and you need to redo the problem. Okay, it could have been a careless mistake. Maybe you added wrong. Maybe you subtracted instead of adding. Just some kind of careless mistake, but these two need to be equal because it's the midpoint. Now, find the answer to this. Find XP. Remember, XP is the whole thing, so 20 plus 20 gives me 40. So X equals 6, and XP equals 40 units. Didn't give me a label. Remember that generic label instead of inches or feet or whatever. We're just going to put units for something like that. All right? So that's an idea of the midpoint. Using some algebra, we could do the same type of thing with a segment bisector. All right? Let's go to our next thing. We're going to go to the midpoint formula. Okay, midpoint formula. So, what that is. All right, midpoint formula. You need to memorize this formula. Midpoint, point in the middle. All right, looks like this. Big parentheses. X sub 1 plus X sub 2 over 2. Comma. Y sub 1 plus Y sub 2 over 2. Parentheses. Okay, so this is not a power. It's not up here. Okay, I see kids put it up here all the time, like an x squared or something. That's not what it means. X sub 1 means the first x value. Okay, the first x value. X sub 2 means the second x value. And the first y value and the second y value. Add and divide by 2. Basically what you're doing is finding an average. Okay, if you add two things together and divide by 2, that's finding an average. Maybe it's your final grade for the year. First semester plus second semester divided by 2. Okay, it's the same idea. You're just averaging, and that makes sense. If something's in the middle, it's the same as finding an average. Okay, so we're going to go ahead and we're going to apply that formula to a question together, and then you're going to do one on your own. Okay, so here's the first one we're going to do. We are going to find the midpoint of -2, 5, and 7, -1. Right, so let's look at that formula, see how it fits together here. Right, can move that down a little bit. There we go. Remember, that's our formula. So we're going to apply that right here. So x1, remember, is first x. Here's my first x value. x2, my second x value. That's right over here. Remember, it goes xy and then another xy. This is my first y. That's my second y. Right? So let's see how we use that. So x1, 1 plus x2 is 5 over 2, comma, -3 plus 1 over 2. Let's do some math. 1 plus 5 is 6 over 2. -3 plus 1 is -2, still over 2. And then let's just reduce and we get 3 comma -1. Now we can check to see if that makes sense. Alright, I actually have this graphed on a piece of graph paper. Alright, so remember we had 1 -3 and 5 -1. Let me zoom out briefly so we can get a little bit more of this into the picture all at once. Okay, 1 -3 and 5 1. So here's my graph. 1 -3. 1, 2, 3, 4, 5 1. Right, that's my segment. Now, my midpoint should be somewhere right in this general area. If it's not, my answer doesn't make sense. I've seen this happen before. -3 plus 1 and somebody puts 2 here instead of -2. And so they come up with 3 comma 1 instead of 3 comma -1. Well, if I were to graph 3 comma 1, that's way up here. Does that look like it's in the middle of the segment? No, it's not even touching the segment. Okay, remember the correct answer is 3 -1. So 1, 2, 3, -1. Let's go ahead and put that dot there. Does it look like that is right in the middle of the segment? Yeah, that part right there is equal to or is congruent to that part right there. So this answer makes sense. All right, what I want you to do is I want you to do this next one right here. Find the midpoint of -2, 5 and 7, -1. I want you to do that one on your own. You find the midpoint of -2, 5 and 7, -1. All right, pause the video, attempt it, and come back and check your answer in just a second. All right, so you should have an answer. Here we go. Let's do our work. So remember, x1 plus x2 over 2, comma, y1 plus y2 over 2. Negative 2 plus 7 is 5 over 2. 5 plus negative 1 is 4 over 2. We're going to reduce. 5 over 2 doesn't really reduce at all, so I'm going to leave it as 5 over 2, comma, 2. Now, once again, I graphed this one. Okay, so let's get the graph out. Okay, you can see it here. Let's zoom out just a tiny bit. Okay, so remember our points were negative 2, 1, 2, 3, 4, 5, negative 2, 5. And then 7, 1, 2, 3, 4, 5, 6, 7, negative 1. We thought the answer, according to our work, was 5 halves, comma 2. Now 5 halves, think about that a little bit. 5 divided by 2, 5 over 2 is 2.5. So 1, 2 and a half, comma 1, 2. Right there. Right on my segment. Looks like it's right in the middle. Those two sections look pretty equal, pretty congruent. Right, so that's our answer. Alright, next one. This one's a little bit different. It's still dealing with the midpoint formula. But this time, instead of giving you x1 and x2 here and here, and then y1 and y2, I gave you the midpoint. Alright, so we have to adjust the formula slightly. This is one of my endpoints. This over here, the thing I don't know, is my other endpoint. So how does that look? Well, x1 is negative 3 plus x2, I don't know. I don't know what x2 is, so I'm just going to call it x. If you want to put x2 in there, that's fine. Over 2 equals the midpoint. Now what's the midpoint? The x value of the midpoint is right here at 1. Okay, well what about the y values? y1 is 1 plus y2, I don't know what it is. I'm going to call it y so I don't get it confused with the x. Over 2 equals the midpoint. The y value for the midpoint is 4. Now, I left these kind of up higher. I'll show you why here in just a second. Easy way to solve this is to put this over 1. I can put any number over 1 anytime I want to. Okay? And then let's cross multiply. Okay, you guys should remember that from algebra class. So 1 times 2 is 2. 1 times all that doesn't change it, so negative 3 plus x. How do we get x by itself? We add 3. Cancel. 5 equals x. Okay, let's come over here and do this. So 4, I can put it over 1 anytime I want to. 4 over 1 is 4. Cross multiply. 4 times 2 is 8. 1 times 1 plus y is just 1 plus y. Subtract 1. These cancel. 7 equals y. So what's my answer? Well, I think it's 5 comma 7. Let's go check it again. I have this one graphed. Okay, so A was negative 3, 1. Right here, negative 3, 1. M, the midpoint, was 1, 1, 2, 3, 4. And I think my answer is 5, 7. So let's see where that puts us. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Up here at B. Now if I were to connect this the rest of the way, does it look like this new section here is equal to, congruent to this section here? Yeah, it looks like it. Do they look like they're in a nice straight line? They do. Right? And we're good with our answer. All right? Now I'm going to give you one of those to try completely on your own. All right? So let me get the next example. I want you to try this one on your own. Lots of papers here. All right, P is the midpoint of xy. This is your x value, your one endpoint, so x and y. This is your midpoint. I want you to find the other endpoint. So set that up like the one we just did. Pause, solve it, and come back in just a second. All right. So remember our formula says x1. So the first x value is 5. I don't even need the parentheses for this. Let me scribble those out. Plus the second x value, the other endpoint, I don't know, so let's just call it x over 2 equals the midpoint. The x value for the midpoint, which is 2. We'll leave a little room there again. Okay, let's set up the y's. y1, my first endpoint, the y value, plus the other endpoint, the y value. I don't know what it is, so let's go y over 2 equals the midpoint, 0. All right, remember I left those kind of up high, so I can always put them over 1 and cross multiply. 2 times 2 is 4. 1 times 5 plus x is 5 plus x. Subtract 5. Cancel. 4 minus 5 is negative 1. Do it over here. Put this over 1, cross multiply, I get 0 equals 2 plus y. Subtract the 2, cancel, negative 2 equals y. I think my answer is negative 1, negative 2. I have this one for us to look at on a graph as well. All right, so here it is. My x value, remember, was 5, 2. 5, 2. P was 2, 0. And I think my answer is negative 1, negative 2. So I'm going to go negative 1, negative 2. I'm going to put a dot. And I'm going to connect this. Does that look congruent to this section, and are they in a nice straight line? Yes? Good. Then our answer looks correct. All right? Next, shifting gears. We're going to go to the distance formula. Okay? Here's what the distance formula says. This is the last thing, and then we're going to do some examples with it. So the distance formula is a big square root, like that. I'm going to start off with x sub 2 minus x sub 1, and then there is a squared right there. Now, some people write this backwards, x1 minus x2 squared. That's fine, because when you subtract, you get the same number, but you might get a different sign. Let's say you did 5 minus 2, you get 3. Instead, you do 2 minus 5 and you get negative 3. Well, when you square it, 3 squared is 9. And negative 3 squared is still 9. So it really isn't going to matter in this distance formula. Okay? It's kind of like what we did with distance the other day on a number line. The order of the segment doesn't matter. So you can subtract in either order. We did absolute value. Here, though, we have to square and do a little bit more. I'll explain that in just a little bit. All right, now continuing, we do y2 minus y1, parentheses squared. And the square root goes over the top of the whole thing. So that's your distance formula, so make sure you get that copied down. Pause it if you need to. I'm going to move on to one other thing we got to look at before we actually start doing this. All right? So get that distance formula written down. All right, here we go. Other thing we need to look at real quick is simplifying square roots. All right, these 5 things right here. How do you simplify the square root of 50? Well, the square root of 50, if you try typing it into your calculator, it's going to give you a decimal. It's like 7.1 or 7.2, somewhere in that range, if you round it off. I do not want you giving me those decimal answers. So, easiest way to do this is to break this down using prime numbers. 5 times 10. And then 10, 5 times 2. So I have a 2 and a 5 and a 5. Pairs go together, and then they move outside the root symbol. Basically what we're saying is this is 2, 5 times 5 is 25. Now we know the square root of 25 is 5, so we're going to pull the 5 outside. And we're going to leave the 2, the single, inside. 5 root 2. Okay, so look at this one. 72, so maybe it's 9 times 8. You might do something different, maybe 2 times 36 or whatever. I don't really care. 3 times 3, 4 times 2, and then 2 times 2. Okay, so let's write them all out. 2 and a 2 and a 2 and a 3 and a 3. Now we're looking for pairs. 2 and a 3. They go outside. This is like saying 2 times 2 is 4. We know the square root of 4 is 2. 3 times 3 is 9. The square root of 9 is 3. So we pull a 2 out, we pull a 3 out. But what do I do with them outside? Do I add them together and get 5? 2 plus 3 is 5. Do I multiply and get 6? Since this is all multiplication all the way through this problem, you multiply on the outside. So 2 times 3 is 6. The single stays inside. 6 root 2. Alright, what about this one? So 4 times 6, 2 times 2, 2 times 3. So I have a 2, and a 2, and a 2, and a 3. Looking for pairs. Pairs go outside. Well, what about both this 2 and this 3? They don't have any pair. They both go inside. What do you do with them? Do you add them? No, remember this is all multiplication, so you multiply them back together, and you get 2 root 6. Okay? Alright, what about this one? 600, this is a big one. 60 times 10. Some of you might have done 6 times 100. That's fine. Alright, 3 times 20. 4 times 5. 2 times 2. 2 times 5. Alright, now don't lose any of these. I have a 2 and a 2 and a 2. I have a 3. I have a 5. And I have another 5. Okay, remember, we're looking for pairs. Pair there, and pairs go outside. 2 times 5, remember we multiply, so 10 on the outside. Singles stay inside. 2 times 3 is 6. 10 root 6. Now, some of you will get really quick at those. You'll get a lot better at them. Some of you might take a little longer doing those, and that's fine. All right, you got to know how to do that, though, before we can move to the distance formula. So now let's look at an example with the distance formula. All right, can't seem to find my paper. Here we go, distance formula. Find the distance between these 2 points. Pause if you need to. Copy that down. We got the point 2, 3. We have the point 4, negative 1. All right, here we go. Big square root sign. x2, second x value, 4 minus first x value squared plus negative 1 minus 3 squared. All right, what is 4 minus 2? It's 2 squared plus, what's negative 1 minus 3? That's like a plus negative 3, so that's negative 4 squared. You must have parentheses around this right here. If you don't have them here, it's okay because that's a positive number. But if you don't put the parentheses here, you'll actually do 4 squared first, get 16, and then you'll still have the negative. But with parentheses, it means negative 4 times negative 4, which is positive 16. Don't lose this square root. 2 squared is 4. 4 squared is 16. Negative 4 squared is 16. Don't lose your square root. Square root of 20. Alright, square root of 20, if you try it on your calculator, it's going to give you a decimal, 4.47 or something like that. Break it down, 2 times 10, 2 times 5. Alright, I have a pair of 2's and a single 5. Remember, pairs go where? They go outside, singles go inside. This is a distance. It didn't tell me what it was, inches or anything, so I'm going to go ahead and put units. 2 root 5 units. Alright, now let me show you why that works real quick. Alright, so I gotta grab this other piece of graph paper. I haven't actually graphed this one yet, but let me show you real quick. So 2, 3. I'm just gonna real quick darken this up right here to be my kind of center point. So 2, 1, 2, 3, right there. 4, 1, 2, 3, 4. Negative 1 is down here. What we are trying to find is this distance right here. Problem is you cannot count that distance because it is diagonal. We can only count horizontally, left to right, or right to left, and we can count vertically, up, down, or down to up. Well, what happens is if I draw a little triangle right here, this is a right triangle. And you probably have heard of the Pythagorean theorem before. Basically, that's what's going on. This distance from 2 to 4, by subtracting, gives me 2, or negative 2, depending on the order. From negative 1 up to 3, by subtracting, either gives me negative 4 or 4, depending on the order. Remember when we did that with the distance in one of our last lessons? We subtracted and took absolute value. Well, here, we go to the Pythagorean theorem instead. Remember, a squared plus b squared equals c squared on a right triangle. Only works for right triangles. Okay, that's what's going on here. So let's look back at our work. Here's my a squared plus my b squared. And if I put equals c squared out here, c being the distance, I don't like this squared, and I cancel a squared by using square roots. That's why there's a square root up over the top. Don't lose that square root. I've seen kids put the square root at the beginning, they lose it here, they lose it here, they forget about it, and they get 20 for their answer. Gotta keep the square root all the way through the problem until you finish it. If you get to the end and it's something like the square root of 100, you don't need to break it down. You should know the square root of 100 is 10. You should know the square root of 64 is 8. Okay, there are certain ones you should just be very familiar with. Right? You do not have to do these on a graph. I'm just kind of showing you why it works, and it's all because of this right triangle, and you are finding c. A squared plus b squared equals c squared. All right, so last example. I want you to copy this down, find the distance between negative 2, negative 4, and negative 5, 5. Copy it down, pause the video, solve it, and then come back and we're done. All right, hopefully you have an answer. Let's take a look. Remember, big square root, x2, negative 5, minus x1, negative 2. Squared goes outside. Plus, y2 is 5 minus negative 4. Squared goes outside. Remember, what do we do with a minus and negative? We treat that like a plus. So negative 5 plus 2 is negative 3. I must put that in parentheses. Plus 5 minus negative 4. 5 plus 4 is 9. I don't have to put that in parentheses because it's a positive number, but I just like being consistent, doing the same thing all the time, so I'm going to do that. Don't lose your square root. Negative 3 squared. Negative 3 times negative 3 is positive 9. 9 squared is 81. Don't lose your square root. 9 plus 81 is 90. Square root of 90 on my calculator, about 9.4, 9.5. It's a little bit under 9.5. Don't like that decimal, so break it down. 9 times 10, 2 times 5, 3 times 3. So I have a 2, a 3, a 3, and a 5. And we're looking for pairs. Pairs go outside, singles stay inside, but I multiply them back together. It was a distance. They did not give me a label, so I'm going to call it units. That is the end of our lesson. So keep in mind what you learned. You learned the definition of a midpoint, definition of a segment bisector, how to use the midpoint formula if I gave you both endpoints, how to use the midpoint formula if I gave you one endpoint and the midpoint, and then how to use the distance formula. You absolutely must get those two formulas memorized. So start working on them now. Don't wait until the night before the quiz to memorize your formulas. You will probably forget them if you do that. We'll pick up with homework in class.